Hello friends, so we have reached to our next video in BRID program, Insight Fellowship program in Advanced Analytical Problem Solving Expertise, and we have started our first, if I may call it a module, Six Sigma Green Belt. So in a previous video, we talked about history of Six Sigma. Prior to that, we talked about introduction to DMAT, define, measure, analyze, improve, and control. We also have gone through example or case study of what was the viewpoint towards excellence in Mazda and that in Ford. So we also spoke about Lean Six Sigma, not Lean Six Sigma here. Six Sigma is Six Sigma is all about controlling the variation by measuring the variation, and standard deviation is the metric which we use, and the symbol of standard deviation is sigma. So let's go ahead and continue our journey further in understanding um, Six Sigma conceptually. Next slide, please. Right. So before we go ahead, let's go through one example again. Lean Six Sigma success stories in biotechnology industry. So intermittently, we are going to come up with Six Sigma success stories so that we all would understand how different industries are applying Lean Six Sigma for that matter in their organization. Please, please forgive me if you get confused when I use the word Lean Six Sigma, because most of times we as such use these words together because these two uh, methodologies are kind of the two sides of the same coin. So we use it together. So in our first or second video itself, we spoke about how lean transformation helped reduce the inefficiency, and Six Sigma helped reduce the variation, and ultimately it helped to improve the performances and solve the problems for the organizations. Right. So please forgive me if I use the word lean and Six Sigma together. Most of the time we do come together. These two are kind of a twins which works together, if I may use uh, the word twins. So Agile and technologies uses Lean Six Sigma framework to streamline $2 billion supply chain. Agile Technologies, a $5.4 billion Fortune 500 global manufacturer providing bioanalytical and electronic measurement solutions in 110 countries. So it's a huge company. This company has achieved significant result in year one of a 3-year supply chain transformation using Lean and Six Sigma converged models. They have delivered a 32% lead time reduction. That's really awesome. That's huge. Lowered inventory levels by almost $16 million and improved productivity by 21% year on year. That's amazing achievement. Again, credit goes to Six Sigma and Lean together. Right. So we started understanding the concept of Six Sigma in a previous video. Now let's move to the next point. So Six Sigma is a state of 3.4 defects or defective parts per million opportunities. So Six Sigma is kind of an ideal state, uh, where you're allowed to have not more than 3.4 defects in your performances when to perform for 1 million times. So if you produce 1 million, 1 million is equivalent to 10 lakh. So when you produce 10 lakh or 1 million parts of products, Six Sigma allows you the mistake of 3.4 defects only. Anything less than that is always going to have the scope or margin for the improvement. That's what the Six Sigma says. So Six Sigma is such a high performance bar. 99 out of 100 is not sufficient in Six Sigma. Even 99.99 out of 100 times, if you're right, it is still not sufficient in case of Six Sigma. Right. So how can you say 99.99% is not enough? Why is Six Sigma that stringent? If this is the question, let's understand the difference between 99% versus 99.99% versus Six Sigma by taking small example over here. So let me go to Excel. So say you're right for 99% of time, and if you're right for 99% of time, you're wrong for say 1% of time. That is 100 minus 99. So like 100 minus 99, which is 1% of time. So in case of 99% time, you're right for 99% of time and wrong for 1% of time. And this is also beyond the acceptance. This is definitely a wonderful situation. Let's go to the next example. When you're talking about 99.99% of accuracy. So accuracy means you're right for 99 out of 99%, 99.99% out of 100. So if you're 99.99% right out of 100 times, so you'll be wrong for 0.01 time. Now let's consider this for 1 million times. So if you're wrong for one time in 100, how many times will be wrong? If you just want to find it out against 1 million. So if you're wrong for one time, so one, so let's do this way, 1 to 1 million, that is 1 into 10 raised to 6 divided by 100. So you will be wrong for 10 thousandths of time. Just a moment. I'm changing the screen, and that's why it's getting a bit difficult. I hope you'll understand it. Right? So let's enter it. So 10 thousandths of time. So 99% means out of 1 million, 10,000 times. So 99% gives you the permission to be wrong for 10,000 times. What about 99.99%? If I may do this way, it's not going to be there. So let me do it this way. This divided by rather into 100 into 1 million, 1 2 2 3 0 4 5 6 0 divided by 100 would be 100 times. So when you are right for 99.99% of the time, you're still wrong for 100 times out of 1 million. And what Six Sigma says, Six Sigma allows you to be wrong for not more than 3.4 times out of 1 million. You can imagine this is a difference. Again, let's get back to our question. Why Six Sigma is that stringent? Do you really need to be that stringent? So let's take a couple of examples where we'll be able to understand it. Imagine a cardiac surgeon, who worked for say 60, 70 long years in his lifetime, and he has operated close to 1 million patients in his life, heart surgeries of 1 million patients. This is a hypothetical case. But imagine, a cardiac surgeon operated over 1 million patients in his life, 60, 70 years. What if a cardiac surgeon is right for 99.99%? Isn't it not good number? That's the huge thing. 99.99% of time, he or she is right in his lifetime, in his or her lifetime. It means 100 patients have lost their lives due to doctor's error in his lifetime. 100 patients lost their lives because of doctor's error. Will we accept it? That is first example. Second example, what if in country like India, railways are accurate for 99.99%? That's 99.99% is beyond any bar, to be very honest. But imagine in the country like India, railways are accurate for 99.99% per year. Will we accept it? When we are saying railways are right for 99.99% of time per year, there are at least 100 accidents per year. Here we are presuming there are almost 1 million, railways, 1 million travels happen. That's again a hypothetical case. So out of 1 million or 10 lakh travel happens per year, there are 100 accidents per year with 99.99% of accidents. And again, let's extend our imagination. For each accident, if say 100 people get injured or loses their life, out of 100 accidents, 100 into 100, close to 10,000 people are losing their lives every single year. So if with 99.99% of accuracy, 10,000 people are going to lose their lives every single year, my simple question is, will we accept it? In both the cases, we will say, no, we will not accept it. And that is why a benchmark as high as Six Sigma is needed. It's not a destination at all. It is a journey of continual improvement. By the end of the day, you have to remember, customers don't even accept one defective product. Whether it's out of 100, out of 1,000, out of 10,000, out of 1 lakh or 100,000 or out of 1 million. When customers are paying you for 1 million times, customers always expect us to give 100% every single time. They will not accept one defective. And that is why Six Sigma is needed. And that is why Six Sigma is that stringent. So Six Sigma is a journey towards becoming best and not stopping there, continuing being the best. I'd like to give example over here of, I don't know how many of us knows if you are not from India, but people who are from India, or for that matter, people who knows cricket, they know Sachin Tendulkar. That is, he is a god of cricket in India. Sachin was the best batsman in late 90s itself, but he continued for next 13 to 14 years to be the best. And that is why he's not the best batsman of that decade, but he's the best batsman of his era, not only of his era, he's one of the best batsmen in cricketing world for the centuries. So he continued being the best almost for 13 to 14 years after he became the best. So he is one of the perfect example of to showcase as far as Six Sigma is concerned. So that's about the Six Sigma. Six Sigma, another aspect of philosophy of Six Sigma is to survive and grow. You have to beat your nearest competition with the greatest margin. The kind of world we are living in, the market and the competition, and we are heading towards future with such a stringent and hard and cutthroat competition. If we really want to survive and grow, we have to beat or defeat our nearest competition with the greatest margin. Six Sigma philosophy, for that matter, analytical problem solving skill set based philosophy help us to beat nearest competition with the greatest margin. Let's take a small example. I would like to take you to Excel again, and we'll just we'll take a small example over here. So this is a scenario. There are three scenarios. Companies that do not implement lean transformation, Six Sigma analytics, or process optimization. And then you have companies that implement lean transformation, Six Sigma. Let me do some change over here. It's Six Sigma. Sorry for that. Yeah, Six Sigma analytics and process optimization. And companies, again, the same that implement lean transformation, Six Sigma analytics and process optimization. So let's consider first two examples, so for that matter, first two cases. Manufacturing and development or service cost almost same, and we'll consider USD as a currency. So it's roughly $45 if 100 is your price of a given unit you're selling. If selling price is $100, 45 is roughly your cost of manufacturing. If it is a manufacturing company, if it is a IT or software company, roughly the development cost is around $45. And of course, if your service industry, like insurance company or for that matter, bank, again, you have your service cost of around $45. Cost of inefficiency, if you're not utilizing analytical problem solving skill sets, as we already talked about, the cost of inefficiency, which is roughly $25. So your total cost would be this plus this, which will give me $70. So $70 is my total cost, and if my selling price is $100, so my profit margin would be 100 minus 70, which would be $30. Now, this is in case of those companies which are not utilizing lean transformation, Six Sigma analytics, and process optimization, right? So let's go to those companies who are regularly utilizing or implement lean transformation, Six Sigma analytics, and process optimization. Intermittently, we also takes few examples as well, as we have taken the example of agile and technology recently. So what would be the manufacturing or development or service cost? It would be same, $45. Cost of inefficiency, I'm not going to say that there'll be $0. It will definitely not $25, but it will be roughly $8 to $10. So after implementing it, they are slowly reducing that cost, and it is no more $25 for them. It is roughly around $10. So $10. What would be my total cost? Total cost would be $45 plus $10, which would be for $55. So if I'll keep my pricing same of $100, selling price of $100, my profit margin would be $100 minus $55, $55, which is almost, if I may make this calculation, 45 into 100 divided by 30, it will be almost 50% higher. So this is what it is. 150 means almost 50% higher profit margin. or the companies who are not utilizing these skill sets. So the companies which are implementing lean transformation, Six Sigma analytics, process optimization would have a relatively higher profit margin over that of companies which are not utilizing it. Now let's go to the curious case, next case. So then in the same, I mean, in case of same companies, I mean, companies that utilize lean and Six Sigma and process optimization. So cost would be manufacturing or development of service cost would remain same, $45. Cost of inefficiency would be $10. Cost or losses we would call when I'm saying cost of inefficiency, it's losses due to inefficiency. You can call it a losses due to inefficiency as well. So my total cost would be 45 plus 10 would be 55, same. Now, interestingly, if I'll decide, well, let me keep my profit margin of 30 here, or maybe 35. So I'll keep my profit margin of 35 over here. So what would be my selling price? My selling price would be 55 my total cost plus 35 my profit margin. My selling price would be 90. So in third case scenario, companies that implement lean or Six Sigma or process optimization, they can have higher profit margin. This is a higher profit margin or their competitors that are not utilizing it. So that profit margin would be 35 minus 30. So almost $5 will get high profit. But at what cost? Almost $10 less cost. So 90 minus, oh, sorry. So to this minus this. So at less, I mean at $10 less selling price, I still can manage profit margin higher by $5. So if I'm Six Sigma implementing company or lean transformation, Six Sigma and process optimization implementing company, I can reduce my selling price, but still I can get more profit margin over my competition. Imagine when you reduce your price by $10, the competitors are selling it for $100 and you're selling it by $90. And even by selling it to $90, you're getting higher profit margin. What do you think your customers will do? If the same product, same quality is got sold for $100 by others and you're selling to $90, customers will come to you. And when you're getting more number of customers with still higher profit margin, that is something an ideal case scenario for any organization. And that is the advantage these companies do gain or are gaining for last 3 decades over the companies which are not utilizing these skill sets. So that's about the example. So let's get back to our presentation. So where were we? Right. So Six Sigma, the philosophy of Six Sigma for that matter, help us understand how to beat the nearest competition with the greatest margin. Now, very quickly, application of Lean and Six Sigma. In a nutshell, Six Sigma due to its ability to provide higher advantage to the customers, it helps to achieve customer satisfaction and increase customer satisfaction. And when you increase customer satisfaction, you get recurring business, and that is why higher market share, higher revenues, higher profits. We took an example and saw this. And when you are having higher profits, you can share it, some profit share with your employees, and then even your employees are also happy with that. And this is across any sector, any domain for that matter. So that's about Six Sigma. Let's go through a few highlights of Six Sigma very quickly. Delivering right product in right time and right cost. This is called a management constraint. These three things, you know, right? You have to have right price means right quality of the product. Right time means delivering in the right time, and right cost means right price. So if you will be in a position to deliver right quality product in the right time to your customers at lesser possible cost, you will be the king of the market, and every single company knows this. But this is not that easy. When you're focusing on delivering right quality product, somewhere you got to compromise on time or for that matter on cost. When you want to deliver on time product, you have to compromise at least on a cost or product. And if you want to deliver any product at lesser possible price, somehow you got to somehow compromise on the quality of the product, or for that matter, even on the time factor or delivery factor. So Six Sigma is a journey for any organization of constantly eliminating problems, issues, and challenges and delivering good to better to possibly best product in low to lower to possibly lowest cost and in fast to faster to possibly fastest possible time, that too every single time. The Six Sigma do build a system for the organizations, of course, with the help of lean transformation and process optimization. This trio can help us deliver better product to best product at lower to lowest possible cost, at faster to fastest possible, in fast or fastest possible time, and every single time. And that's the power of Six Sigma. So let's go to the next slide. The next highlight is the fundamental relationship between Y and X. So problems are symptoms, or problems are output, and it depends on something, you know. So when we are seeing some symptoms, there's something behind it that is called cause, the input factors, or for that matter, the causes. And these causes, most of times, or not most of times, always lead to the symptom, or always lead to the output, or always lead to the problem. So in nutshell, if you're having any problem, be assured that there are few causes behind the problem which we got to fix. And if we are going to fix those causes, that will help us improve the performances of the why, or performances of the problem. In other words, fixing the causes will lead to fixing the problems. So why is process output a problem which we monitor and trying to improve? It depends on X's, which are nothing but process inputs or causes, which we got to control. And that's the relation between Y and X. So Six Sigma prioritizes significant X's that impact Y, that too based on statistical validation. Now this is very interesting thing. So can we say before Six Sigma, prior to Six Sigma, there was no problem solving methodology available? No. If you ask me, since the evolution of human beings, from that time, from last thousands of years, human being always had a problem and always found a solution to solve those problems. So we used to solve the problem before Six Sigma as well. But what Six Sigma did is a very significant thing. It helped us find out important causes behind the problem. Yes, prior to Six Sigma, there were methodologies that also used to trust or believe that if there are any problem, there are certain causes we need to fix so that performance of why a problem will also get improved, also get fixed, right? So y is equal to function of y is a function of x. This relation was already there established into the system prior to Six Sigma. But what Six Sigma did help us prioritize those causes. So take an example that if you have a problem A and we somehow could able to find there like 15 different causes or 10 to 15 different causes. Now the question is, can we work on those 10 to 15 different causes? It will consume time, it will consume efforts and money as well, right? So we cannot somehow invest that much of time, that much of money, or that much of efforts to solve that problem. Or it would be challenging to put that much of money or invest that much of money, efforts, or time to solve that problem because that is not the only problem companies do face. Say in 365 days or in a year's time, every single company do face more than 100 different problems. Now, to solve those 100 different problems, there's a roughly three causes for a problem. And for each cause, if you're having one solution, there'll be 300 causes and more than 900 solutions to work around. And companies cannot invest that much of time to resolve this. Now, if you not resolve those problems, losses due to inefficiencies are going to mount, losses due to inefficiencies are going to increase, and that will also going to affect your business. So you got to have something a balancing principle in between, which can help you not to invest that much of time and money and effort, but at the same time help you resolve those problems. Six Sigma come to rescue us here. Six Sigma says based on statistical or scientific testing, what if I'll help you find out 50 most significant causes out of the list of 300 causes you do have? Can you work on a 50 causes? Yes. To work on a 50 causes, I might spare less amount of money and time and efforts than working on 300 causes. But how Six Sigma do it? By using statistical testing, Six Sigma helps us prioritize those significant cases. Now, how Six Sigma do that? Of course, in upcoming videos, we're going to see it in details. But for time being, all we need to remember when y is equal to fx, when y is a function of different x's, Six Sigma help us find out significant x's out of those different x's, out of those many x's based on statistical validation. On that note, let's go to the next slide. Right. So another highlight of Six Sigma is hierarchy of Six Sigma. Right now you are learning Six Sigma Green Belt. So different hierarchies are there for Six Sigma. It started with, I mean, when I'm saying Lean Six Sigma, as I already talked about, it's two sides of the same coin. So you do have a bottom level team members who normally work on Six Sigma projects. Those are yellow belt people. Green belts, which you are going to be, are the ones who lead those Six Sigma continuous improvement projects, cost saving projects, profit maximization projects, customer satisfaction enhancement projects. So you're going to lead those projects. Black belt is one level up to green belt. All black belts do is they help green belt execute the projects. So they mentor green belt to execute DMAT procedure. And master black belts are at the top, who are the one who help black belts in their activities, in their work. It might be training, it might be deploying the whole program. They're the one who are responsible to deploy the whole business excellence program or whole program under which multiple problems you will solve with the help of black belts and green belts. Likewise, just yellow belt is a ground level, green belts are the project leaders, black belts are the mentors who mentor the project leaders, that is green belts, and master black belts are the one who mentor or train black belts. This is the hierarchy of Six Sigma. Let's go to the next slide. So I guess here we are done with the highlights of the Six Sigma, and these are the few examples of the companies who deploy Six Sigma. These are just few of them. There are thousands of companies, more than 25 to 50,000 companies that do deploy Lean and Six Sigma and process optimization today in the world across the industries. You can see Bank of America, which is a finance company, where Sony, it's an electronic company. Alive Signals is also electronic company. IBM is here, which is a technology company. Coca-Cola is here, which is again a beverage-based or soft drink company. GE is there. So different companies from different sectors, from different segments, from different industries do utilize Six Sigma and get benefited with Lean, Six Sigma, and process optimization based problem solving methodologies. And that too for last more than 3 to 4 decades. That's about a few examples. Now almost we are done with the introductory aspect of Six Sigma. An upcoming video will go and try to understand, or rather we'll start understanding how to deploy DMAC procedure. So we're going to start with define phase in upcoming video. For time being, let's go through few questions quickly. The Six Sigma is ideal state of blank defects or defective parts per million opportunity. So is it 3.4, 34, 4.3 or 43 defects or defective parts per million opportunity? What is the answer? The answer is 3.4. Six Sigma is ideal state of 3.4 defects per defective parts. Six Sigma is ideal state of 3.4 defects or defective parts per million opportunity. Next question. Six Sigma means 99.99% of accuracy. Is it true or false? It is much beyond than 99.99% of accuracy. So this statement is absolutely false. Imagine 3.4 defects out of 10 million. So how are you going to do it in the form of percentage? It will be roughly 99.99997, almost 99.99997% of the accuracy. So which is higher than 99.99% of the accuracy. Final question is, Six Sigma prioritize significant excess or causes that impact Y, which is my problem. That too based on statistical validation. Is it true or false? The answer is true. Six Sigma is a prioritization methodology that prioritize significant excess that impact Y, that too based on statistical validation. And statistical validation comes with higher accuracy. So this is what we do have in our today's video. Thank you so very much for your time today. In upcoming video, we'll start delving deeper into DMAC methodology, starting with define phase. So Uttishta Bharata, Ma Bharati shall rise again in a full glory. Thank you so very much. And finally, before we end today's video, let's thank technology companies for their technological support. So we deeply appreciate following technology companies for their technological support. this note, thank you so very much for your time. Let's meet up in the next video. Thanks a lot and have a wonderful time ahead.